cryptography proper. Okay, and I have sent that message as 1110. Now the second person B is seeing that 1110. So the main motive, the information sharing is not there. Okay, I am sharing just some random data, the ciphertext. So what I need to do here, if I have encrypted that data, so I must share the decryption key. Okay, or I must share the idea of decryption. Okay, I have to send an analogy that how you are going to decrypt this data. So in general case, we have different option. Okay, first thing, I can directly communicate the second person and say him that okay, whenever I will say 001110, just read it as hi. But this is a very lengthy and like not sustainable process. We cannot sustain our business on this type of conversation. Okay, this is the 100% secure, but this process has lots of limitations. So what we are doing, we are using two approach here. The first approach is the same encryption method will be implemented for decryption also, like reverse of that method. And the second approach is we are creating a different algorithm for encryption and different algorithm for decryption. But the point is that authentication. Okay, suppose I am communicating via a network. Okay, let's take an example from old days. Take an example of a bird. Okay, suppose two kingdoms are there. Now they are sharing the information in an encrypted format, and they have set up a rule that from this rule only if you will convert this text, then you will find the proper message. On a very first communication, the first person or the sender must send that rule with the bird itself. Okay, so if someone wants to view the message, so he will capture the bird and see the algorithm. After that, he will release the bird. Okay, go to your destination. From this point to end of the communication, he is a person with MITM, like man in the middle. He's seeing everything, right? The same thing happens in network too. Whenever we are sending a data, so anyhow we have to send the decryption also or the encryption headers we have. So anyone can see that. So that's why what we are implementing the authentication. Okay. So we are encrypting the things and the first line of decryption will be authentication only. Okay. So the key will be revealed to authenticated person. So these things are the very basic of cryptography. Let's get into it. So the first thing is secure communication. We are implementing cryptography for secure communication. Now needs and requirements. Let's see what is the need and requirement of cryptography. Like well-established needs for secure communication, like wartime communication. Then business transactions and elite love affairs, like these things. Okay, so when it comes to wartime, I have taken the example. It is not always the wartime. It is related to some kind of uh, defense or army related data. Okay, that data must be very secured. Then business transaction. Transaction may be of money or maybe of intellectual property. Okay, these things you need to understand that in cyber security or in information security, uh, money is not the big thing to protect. We have the data, and when it comes to intellectual property, these all are very confidential data. Okay. Do anyone know here the Coca-Cola story? The Coca-Cola recipe story?
Yes, sir.
Yeah, what was that? What is
An employee from Coca-Cola offered Pepsi to, you can say, breach the recipe of Coca-Cola and uh, sell it to the Pepsi.
yes. Then Pepsi itself reported to Coca-Cola. So that is, but in information security, when it comes to information security, even Coca-Cola or Pepsi didn't go for patent till now, because in patent they have to reveal their recipe for patent file, right? So they have secured their recipe in any vault or something, stories like that. But the thing is, they didn't register the patent because they believe that in future maybe if government website or government data will be hacked, database will be hacked, or any data breach is there, so my data will be lost. So that is like business transaction. And Coca-Cola is example. Every business has some intellectual property. Nowadays, if you go for any startup, so they are keeping these things very private. Okay. Also, in business, you will find that okay, when we are working in cyber security, we have some ethical values, right? Our ethical values is towards our society as well as the organization. In organization, lot of work are there, which seems to be not very legitimate. But as a security person, it's our responsibility to secure them too, right? So that all comes in business transaction. Then elite love affair. It is not only that love affair, any boyfriend girlfriend like things. It may be any kind of relationship between elite people. Okay. Then the requirement of secure communication. First thing is security. Only intended receiver understand the message. Then authentication. Sender and receiver need to confirm each other identity, and the message integrity. Ensure that the communication has not been altered either malicious or by accident during the transmission. So these all are the requirements for a secure communication, and we have to fulfill this requirement. So how we are going to fulfill this requirement? Let's see. To fulfill, we have to fulfill all these requirements. We have cryptography. The basic is cryptography is the science of secret or hidden writing. Okay. So it has two main components: encryption and authentication and integrity. So encryption mainly we have practice of hiding messages so that they cannot be read by anyone other than the intended recipient. Okay. Then authentication and integrity, like ensuring that the user of data resource are the person they claim to be, and that a message has not been completely altered. Okay. So here the basic things are there. In encryption, we are converting the format, mainly converting the plain text to cipher. And when it comes to cryptography, we are also adding authentication and integrity. So in encryption, we have something known as cipher. Cipher is a method for encrypting the message. So here we have an analogy, like we have a plain text, then we have an encryption algorithm, and that algorithm stored in a key. There, with the help of that algorithm, the plain text is converted into ciphertext. Then we have decryption algorithm, and decryption algorithm convert the same the ciphertext into plain text. This is very simple. I hope that all of you can understand by the image only. Okay. So encryption algorithm are standardized and published. The key which is an input to algorithm is secret. Key is a string of numbers or character. if some key are used for encryption, if same key is used for encryption and decryption, the algorithm is called symmetric, and if different keys are used, so the encryption is called asymmetric. Okay. Now just remove the key B and the decryption block. Okay, just remove the key B and replace it with key A. Then it will known as a symmetric encryption. We are using the same key for encryption as well as for the decryption. Okay, but when we are using two type of key, okay, so this is known as asymmetric encryption. Let's see the symmetric algorithm in which the key for encryption and decryption are the same, are symmetric. Example is your like process cipher. It's have it's have two type like block cipher. Encryption encrypt data one block at a time. Typically, it is in 64-bit or 128 bits used for single message. And stream cipher is like encrypting data 1 bit or 1 byte at a time, used if data is a constant stream of information. Okay, so basically we have two types in symmetric, like the block cipher when we are using it. Okay, so what it say? Encrypt data one block at a time, typically 64 or 128 bit. When we have proper stored data, okay, suppose you have 2 GB of data. So you know that only for 2 GB data I have to implement this. So you are dividing that data into different blocks. Block size mainly available in 64 bits or 128 bits. Okay, used for a single message. So like for every recursive algorithm, you are encrypting a single block, and that block will go into the network or where the path will be. Okay, so it can apply on the stored data, or you consider the data which is in rest. In very simple, the data which is in your hard disk or database. But when take example of continuous generating data. Okay, like this live session. Here, what we are doing, we are continuous okay the information. So when it comes to encrypting these type of things with the help of symmetric, so we are using stream cipher. Now encrypt stream cipher encrypt data 1 bit or 1 byte at a time. Here we are taking the smallest unit, like single bit. Why? Look, when you will store the data, you have a fixed figure. Okay, it may be 1 GB, 2 GB, or 10 GB or anything. So when you are implementing your algorithm, so actually what you are doing, you are calculating the overall mass, okay, overall weightage of data, and if it if it have suppose 1 GB, 1.001 GB is there, okay, or 1.00001 GB is there. So what it will do, the block cipher, it will add few of the uh, memory blocks to same for proper implementation of algorithm. Okay, but in live data or in continuous generating data, it is not possible. So here what it is doing, a single bit, whatever we are transferring, whatever the data is transferring, either in bit or in byte format. So it is encrypting the individual one. I hope that all of you got these 2 points, block cipher and stream cipher.
Yes, sir.
Yes, sir.
Now let's see the key strength. The strength of algorithm is determined by the size of the key. The longer the key, the more difficult to crack. Okay. Now key length is expressed in bit. Typically, key size varies between 48 to 448 bits. Set of possible keys for cipher is called key space. Okay, for 40-bit key, there are 2 to the power 40 possible keys. Okay, I will explain. To crack this key, the hacker used to brute force. Okay. Now, what this slide is saying? First thing, we have the uh, strength of key. Okay, the strength of algorithm, or you can say that strength of key. So we are deciding it by the by our key size. So we mainly key size, our key size varies between 48 to 448 bits. Okay, if you will take the 448 one, so it will reflect that your algorithm is robust and very hard to crack. Okay, but if you will go for the less one, then the possibility of cracking will be high. Now, set of possible keys for cybertext is called key space. We have a term key space. Okay, suppose you have taken for 48. Take this example. So, what are the possible combination? Okay, or what are the possible key maybe for that algorithm? So here we have a simple like 2 to the power 48 if we will go for 48. Okay, so this much possible keys will be there. Suppose you have taken 5 bit only, so your possible key will be 2 to the power 5. What is the value of 2 to the power 5?
32.
कितना टाइम लगेगा एक सिंपल कैलकुलेशन में? Okay, let it be. Look, in cryptography, what I will recommend, if you have a very good command in mathematics, then only go deep in cryptography. Cybersecurity have lots of domain, but for cryptography, what I will recommend, if you want to be in cryptography, well, if you are in cryptography, then believe me, you will be going well-paid job. In cybersecurity also, cryptography have a, like extreme level of reputation as well as money. But for this role or for this domain, you need a good command on mathematics. Okay, cryptography is all about mathematics. So, if you will go for 5, then 32 combination. Now, let's take an example of brute force method. So, 32 is not a big number for brute force. But if you will go for 448, so what will be the what will be the 2 to the power 48 value of 2 to the power 48? Okay, so it may be in, let me also calculate. It's 7268387 E plus 143. My calculator is also not able to calculate. So look, the complexity level, right? In this case, you can say that if you are going with 448, then the although hacker have all everything to get the key, okay, but the difficulty level is very high, right? Here in 440, the same approach attacker will use for 2 to the power 5 one. Okay, if you have taken the 5 bit, the same approach attacker will take for 440. But for 5 bit, it will take 15 to 20 minutes. But for 448 bit, it may go, the time may go up to 10 year or 20 year, right? So That's the basic fundamental. That's the basic of key length or key strength. Okay. Now in third point, we have to crack the key. The hacker has to use brute force. Okay, brute force. I hope that all of you know what the brute force is. Okay. And then seizure cipher. It is the method in which each letter in alphabet is relocated by three letter as so. Okay, so these all are the basic things. I hope that in aptitude you are solving this kind of problem, right? That if A will be D, B will be E, then what is the value of U? So you are just adding three. Okay, so nothing to explain here. Okay, we have a just a practice here. If anyone wants to do a fun game, so in your group you can do this thing. It will enhance your like cognitive skill. Now, suggest cipher encryption like plain text, then cipher and cipher. So it basically represented the same thing for this one, the graphical one. So in this only, what is our key and what is our algorithm? So algorithm is like index value of alphabet plus 3 plus 2 if we are going for index value. So index value of A will be 0, for B 1, for C 2. Okay, so if we'll add like 3 more in it, okay, so we can find the F. So the same thing will be here. Then we have something known as mono alphabetic cipher. Any letter can be substituted for any other letter. Okay, so these all are the basic things. I will share these slides to you. Okay, and for your practice, because look, these type of questions are not very important in cyber security work, but are very important in cyber security first round of interview. That your it may be your any MCQ type question. So in that MCQ type question, you are definitely getting these questions. Okay, so do some practice on this type of question. Then we have polyalphabetic figure cipher developed by uh, Lice and Vignere. Lice and Vignere, also called as Vignere cipher.
Sir, it's Viniere.
Vignere.
Yes.
Okay, thank you. Actually, the English name, it's very hard to pronunciate, right?
Yes.
And so I am not very good in English. I hope that in this 1 month you guys have got the idea that my English is little bit. Okay, I know little only. Okay, so let the English be a way of communication only. I hope that all of you are getting my words properly. Okay, or you are getting some time problem.
No,
No,
sir,
sir.
it's fine.
No problem at all.
No,
Means
sir, no problem.
okay, so means you are able to understand my grammatical errors and all. So that will be very good for me. I'm not going to fix that. So let's see what is there. Uses a sequence of monoalphabetic cipher in tandem. Okay, so the plain text, then we have C1, C2, then 620. What is this ky? Okay, so in this, what it is doing? It uses sequence of monoalphabetic cipher in 10. Okay, so it is taking two strings. For one, the value will be 6, like 1, 2, 3, 4. Yeah, 6. So for AF, then for second string, the value will be 20, and by these two, your output will be there. Then we have using a key to shift alphabet. Okay, obtain a, hmm. So obtain a key for the algorithm and then shift the alphabet. For instance, if the key is word, we will shift all the letter by 4 and remove the letter. Okay. So we have to ensure that the mapping is 1 to 1. So basically we are doing this. Okay. So this in first we are mapping like this. Uh, like if we have k value is equal to 6, so we are moving the overall index value plus 6. Then we have k value is 20. So what we are doing for this, we are implementing that, right? Like for this, we are implementing this. So these all are the basic. Then we have column columnar transposition. Okay, so what we are doing, we have a plain text like this. So what we are going to do, so it's a column. So we are looking for the column like TSSOH. So we in ciphertext, our text will be reflected CSSOH. Okay. So we are shifting the dimensions. Okay, these all are the very basics. Okay, in computer networking, we are not implementing any one of them. In computer networking, we have different thing. That's why I'm bypassing this slide, not explaining very briefly because this is for your like practice only. In examination, you are not going to get a real encryption to break. You are getting these things only. Now cipher. Sonon's characteristic of good ciphers, the amount of secrecy needed should determine the amount of labor appropriate for the encryption and decryption. Okay. So when we can say that any ciphertext is good. So the first point we have, the amount of secrecy needed should be determined, the amount of labor appropriate for the encryption and decryption. So if we have written an algorithm for encrypting, then it is not like that. We can say it is not like that the algorithm cannot be break. It can be break. Okay, we have 100% possibility that it will break. But what we are doing, we are giving the complexity part in reverse engineering. If someone wants to break that, so they have to put a high amount of labor. And look, high amount of labor, you have a single problem, right? So you will solve that problem by a single resource. Okay, you cannot implement a multiple resource. The resource may be powerful, the resource may be low powerful, right? But you need to use a single resource for a single problem. So suppose you have used a robust or very advanced algorithm, then also it can be great. But the time what is going to take by that machine who is working to break, we are increasing that time period by us, like by our algorithm. So that is secrecy only, a security. Okay. The set of keys are the set of keys and the enciphering algorithm should be free from complexity. Just give me a second. Now the set of key and the enciphering algorithm should be free from complexity. Means what we are having or what we are keeping with ourselves, that should be that should be free of complexity. Then the implementation of process should be as simple as possible. Now this point is very important. Whenever you are creating or you are deploying any algorithm, so you have to take care that the implementation should be simple. Okay. Why I have said that in why I like this point is mentioned here. Go to the starting of session. I have that you example of that word. Okay. Now that is a encryption. And what you can do, you can send your encryption and decryption algorithm by a soldier. The king can send that and by a soldier. And when the second party or the receiver will get that, they will fly the word. Now come to practicality. Is it practical? Yes, is it? But the complexity level is too high, and the latency will be go higher. First, our soldier will go deliver. Then we will wait for the acknowledgement. Then soldier will come. Okay. Then we will prepare a bird. We will fly the bird. Although if someone will catch the message in between, it is near to impossible to for the person to read that message. Okay, but that is very complex. So in technical terminology also, if you have created a very good algorithm, but when it comes to implementing, you will find that all of the system resources and network resources are wasting in encryption and decryption only. Then what you are going to do? Due to your encryption or due to your cryptography algorithm, the overall latency will go up to 5 seconds, 10 seconds. So we cannot afford that too. Then errors in ciphering should not propagate and cause corruption or further information in the masses. So this point is important. Let's understand it in easy word. Any algorithm is there. So error may be everywhere. Okay. It is not like that we can a system without zero error. Maybe today there is no error, but tomorrow there may be few errors. So what our algorithm will be like, if any error will be there, maybe any error will be there. So what it will do, instead of processing with that error and showing a unrelated or duplicate message or corrupted message, it will show the false and it will not decrypt the things. Okay. The same thing for encryption. If some error is there in encryption, so the algorithm must be stopped there. It is not like that the algorithm will go with that error. There may be some minor or major error. Because when it comes to communication, for a single bit, your overall data will be changed. Then the size of enciphered text should be no longer than the text of original message. Okay. So the overall size. Now, when we are talking about size, it is not like the size of that message. Suppose that HELLO there. So we are showing that HELLOOO. This is not the size. Size means the memory consumed. Okay. Because when on any information when we are converting it into data and we are implementing something. So there may be some data type changes or variable changes or value changes. So we have to do the prevention from that too. Okay, take an example. If a number is one there, what type of data is one? Yes. What type of data is one?
Plain text.
Okay, do you know the basic data type concept?
Okay, sir. Integer. Yes,
Yes, integer. Or if I will write 1.0, then what type of data is this?
that's float.
Float.
Float. But if you will read 1 and 1.0, the information is same, right?
Yes, sir.
Yes, sir.
Yes, sir.
So when we are implementing the encryption or the cryptography, we have to take care of this too. Because in overall process, there is a high chance that your data type will be changed. Because sometimes you are converting the text data, like the text data into integer type of data, integer to binary. Okay, yes, it affect memory space. So we have to take care of that too. Now encryption system properties of trustworthy system. Properties of trustworthy system. It is based on sound mathematics. Good, good cryptographic algorithm are derived from solid principles. The first thing, common thing, there must be a solid principle for any algorithm. It has been analyzed by competent expert and found to be sound. Okay. Since since it is hard for the writer to invent all the possible attacks on an algorithm. Okay, what he's saying. Okay, so when we are creating any kind of algorithm, so there must be an proper analysis must part is there. We have to go for all possibilities. It is not possible to go for all because maybe some new trends or new kind of attack will be there. But we have to check for all possibility or all available possibility. It has stood the test of time. Over time, people continue to review both mathematical and foundation of algorithm and the way it build upon those foundations. The flaws in most algorithms are discovered soon after their release. Okay, so what is test of time? Okay, so there is a case study. Okay, let me explain you case study. Just give me a second. Okay, I'm not getting that document. If there is a case study, like a very good case study on this. But I'm not getting that document. Okay, let it be. If I will found, I will share that document. I will share that document with you. Then we have something known as cryptanalysis. Not techniques. Cryptanalysis is the process of breaking an encryption code. Okay, so we have several techniques can be used to reduce the algorithm. Basically, what is this? This is the part of getting into algorithm or breaking the algorithm. Attempts to recognize the pattern in encrypted message. Okay, so I hope that all of you have done that pattern matching problem in DSA, right? Have you ever solved any pattern matching problem in DSA?
Yes, sir. The star one and the alphabet, like pyramid one and all that you're talking about.
No, that is a creation of pattern. In text, we have some pattern. Okay. Suppose I will give you a problem like from any set of string, you have to extract all the combination which are in 3 to 1. Okay, and the string may be 100 digit or 200 digit. So what you are going to do? First, you are checking for 3. If 3 satisfied, then you are going for 2. If 3 and 2 satisfied, then you are going for 1. Okay, if 3 and 2 are 3 and 2 are satisfied, but 1 is not there, so you are starting the analysis from beginning plus 1, right? So
Okay.
so that is a method of that is also a method of cryptanalysis, right? We are finding the encryption algorithm with that process too. Okay, so okay, that is very basic problem of DSA. You guys just do that. Okay, that is very important in cybersecurity or in any IT field. When you are going for the first time, so they may ask this type of question.
Okay, so like the way we make brute force directories like that I'm talking about. From a specific string, we
Okay,
make brute force
brute
directories.
force directory is very different thing or very higher thing. It is on
Oh,
low level.
oh,
Okay,
okay.
let me explain. Suppose 1, 2, 3. Okay, 1, 2, 1, 2, 1, 2, 1, 3. Now tell me one thing. You have to find all the pattern which contain 1, 2, 3. So just think like a techie person, what your system is going to do. So
First,
first
it
you
will
yes,
first it will go till 1. Then it will check the original string that 1 exists in the original string. Then it will go further to 2. Then it will check if it is in the original string. Then it will further go and check whether it's 3 or not. And if it is not 3, then we'll start from 2 next time.
yes,
Then 2 1 2, then 1 2 1, and all that.
yeah. So like this we are going to do. So these all are the basic problems. Okay, and that's why in starting I said for cryptography math is important. The same pattern matching we are doing for find the same pattern matching we are doing in cryptanalysis. Now attempt to infer something meaning without even breaking the encryption, such as noting an unusual frequency of communication or determining something by whether the communication was short or long. Okay, now the second thing is, okay, let me explain. Okay, we have 1 plus 1 is equal to 2, right? This is the simple thing. Now, if 1 plus 1, you will find, so you can say that the answer must be 2. Okay, but what if answer will be 4? What you can what you can analyze from here? And then you have 1 plus 2 is equal to 6, and 1 plus 5 is equal to 12. Okay, delete this one. Plus 2 is equal to 8. Now, can you say me if this is your output? Output can be determined by any communication. Okay. So what will be the value of 1?
2.
Yeah. And what will be the value of 5?
That's 2 into 5, 10.
How you can say that the value of 1 is 2?
Like multiplying 2 with 1 and then adding again 2 with 1, that gives you 4. By determining the output, we can change the values of digits based upon output.
Yeah. So we are now, if suppose any algorithm is there, anyhow algorithm will show the output to us. Okay. If we will create a legitimate connection, it will show us the output. And creating a legitimate connection is not a big task. So by the output and the encrypted text, sometimes we can find what will be the actual text. And when we can find the actual text plus encrypted text plus output, so we can say that we can find that what is the algorithm, right? In this basic example, we have done the same thing. We have encrypted text 1, 2, 5, everything is encrypted. We have output, and we know that what is the process. Okay. Now let's take an example. If I will give you this much information, can you say what is the value of 1?
No, sir.
Why?
There might be multiple options. Insufficient information to
Can be
support our outcomes.
Yeah. So that's how we are breaking into encryption. We are breaking into an algorithm by multiple output and the encrypted thing. Okay. This vulnerability was there in that ND5. Okay, you can go with that case study. Then attempt to deduce the key in order to break subsequent message easy. Then we have attempt to find weakness in the implementation or environment. Okay, these all are the basic. Sometimes we have algorithm, we have like policy failure or in cryptography failure. So these all are the vulnerabilities. Attempt to find general weakness in an encryption algorithm without necessarily having encrypted any message. So these all are basic vulnerability, but the main thing is the first thing what we are doing to okay, this is for symmetric one only. So what we are first thing doing, the pattern matching. Then what we are going to do, doing the analysis to break into algorithm. Then we will find for any kind of vulnerability implementation error. So some human errors are there, right? So we are also looking for that. Now we have data encryption standard DES. The goal of DES is to completely scramble the data and key so that every bit of ciphertext depends on every bit of the data and every bit of the key. Okay, DSC is a block cipher algorithm encoded plain text into 64-bit chunks. One, mm, one parity bit for each of the 8 bytes. Thus, is reduced 60 56 bit. This is the it is the most used algorithm. Okay. So what DES is saying? Okay. So the main goal of the DES is like completely scramble the data and key. Okay. So in this example, you can see that we have a pattern and we have a shown algorithm, right? But what but what if I will say 1 plus 1 is equal to 4, then 1 plus 1 is equal to 5 and 1 plus 1 is equal to 6. Now it is near to impossible to do the same thing on these three, right? Because on the same exposed information you have three different outputs, right? So but one prediction is there that for everyone the plain text will be 2, and for every recursive there may be plus 1, there may be a condition of adding 1, right? That 2 plus 2 4 plus 2 plus 2, as this is the first recursion, so we are adding 1. So 4 plus 1 5, then from last one we have 5, so we are adding. So but these things if you will create by yourself, then only you will know, right? So the similar type of things where was there in DES. Okay, so it is member in data and key, so that every bit of ciphertext depend on every bit of data and every bit of key. Now suppose this is our data, and after encrypting this data our key value will be changed. So we like key here key value is 0. So on the first recursion 2 plus 2 4 and key value is 0. Now here 2 plus 2 and now key value become 1 on second recursion, then we find that 5. Now we will add 1 in key value. So you can find that on every recursion we are changing the data as well as the key value, so it will become a robust system. But then also we have a pattern. It is not like that it cannot be hacked, but it is standard approved by US nation runs of standard for commercial and non-classified US government, okay, used in 1993. So this one is achievement of this algorithm. Let's see some other. So we have DES, triple DES. So in DS we have key size 56. It's implemented on block cipher. Okay. In triple DS we basically doing the DS 3 times. Okay. Then we have blowfish for block. Now for blowfish we have a key point that its key size vary. Its key size vary from 48 to 448, and it has excellent security. Then we have AES. It's also implemented on block cipher, and its key size also vary from 128, 192, or 256 bits, and it is a replacement for DES, and it have excellent security. Okay, one point you can notice As the algorithm trend increase, you can see that the key size, it is like increasing and become more complex. Here we have simple 56. Here we have 168 but 1112 effective. Here we have variable up to 448. But here we have variable in three different categories. Then here we also have variables only. Okay, so RC4, it is for stream cipher. Okay, fast stream cipher used in most SSL implementation. Then symmetric encryption limitation. Any expose uh, any expose to the secret key compromise secrecy of ciphertext. A key need to be delivered to the recipient of the coded message for it to be deciphered. Okay, so it have only one limitation. You have created complete robust system, but anyhow, if I will found the key, your whole system will be available for me. There is no any authentication or authorization is there, right? So that is the main problem because our overall complexity and dependency lies on key only. Okay, so today we have completed the symmetric one. In one more session, I will try to complete the asymmetric. Any doubt till now?
No, sir.
No, sir.
No, sir.
Means if you don't have any doubt, means I have delivered a boring session, right? Because in any
No.
interesting session, there must be a doubt.
Sir, all the basics are clear though. I mean, knowledge is infinity.
Okay, well, cryptography is a lengthy topic, I know. This is complete math, and you people are very good in hands-on, right? You want direct live hacking. So what I will recommend to you, so that will क्या करता है तुम्हारे पर्सनैलिटी को जचेगा एंड तुम क्रिप्टोग्राफी भी थोड़ी बहुत सीखोगे. आई विल recommend you some of the website where you can do some practice on cryptography. The first thing we have crypto hack, like cryptohack.org, you know.
No, sir.
Okay, I am sending the URLs in message only so that you all can use it. Because I know sometimes theory are boring, but what I can do, I will suggest you some of the practice. Yeah, I will send the PPT, don't worry. After the session, this message will be deleted, so I will request all of you just copy these things. Okay. If you will do some practice on these three platforms, you can choose any one. I gave you three platforms. So you will definitely get some of the insight and some interest in cryptography. Also, I will share the PPT and remember everything. Now to ratta maar do. What I will recommend, rat ke jao. But before going to interview, go for the basic of cryptography. Even you are in red teaming, blue teaming, any position, even for network engineer, they will ask some of the questions from cryptography. It is from my personal experience. अभी तक मैंने जितना इंटरव्यू दिया है, क्रिप्टोग्राफी 101% मुझसे पूछा ही गया. एंड इट इज लाइक कोई बहुत डिफिकल्ट नहीं, बेसिक पूछेंगे. जस्ट पता नहीं क्या है, वो कहते हैं ना, तेल का राई हो गया है कि कुछ भी सब्जी बनाओ जीरा सरसों डाल दो, वो जीरा सरसों हो गई क्रिप्टोग्राफी. कोई भी पोजीशन है पूछ लो क्रिप्टोग्राफी. Okay, so I'm binding up the session here. Any doubts or any discussion? Okay, so thank you